Hey everyone, welcome back to Chemistry 1, where this video's topic is going to be about finding empirical formulas. So we are actually finding the empirical formula of a compound. I'm going to write here that a compound is made up of different elements. So just going to give an example, you have A, B, and C, and it has specific subscripts that I'm going to put as we don't really know. And that's what we're trying to find that will make up what is called the empirical formula. We can determine a compound's empirical formula if we know its percent composition. So when we say percent composition, we are talking about what it is composed of element-wise and how much percentage of it is A, how much percentage of it is B, and how much percentage of it is C. So I have out here outlined a process that I find helpful in doing these problems. So the first thing you're going to do is you're going to go from, sorry, I don't know, why is this being difficult? Grams of each element in the compound. So you will start with something that we know is grams for the most part. Then you're going to go from grams to mole of each element in a compound. And we know how to do this from previous videos. So we're going to go from grams to mole. Remember when I was talking about that sometimes, for the most part, you'll start from grams? I said most part because sometimes in the problems you're given, they will go to mole. So the problem will say you have X amount of moles of A, X amount of moles of B, X amount of moles of C. Or, for the most part though, the problem will say that you have X amount of grams of A, X amount of grams of B, X amount of grams of C. And that's because they want you to do the most work to find the problems. But if it starts out with mole, then you've kind of already skipped the first step. Okay? So then once you go from gram to mole, you are going to go and divide each mole amount by the smallest mole amount calculated to get each element subscript number. So, for example, if you have a compound and you found the moles of each of these, so you found this moles of A, moles of B, moles of C, whatever mole amount is the smallest, you're going to divide by. So you're going to have, let's say, example, 3 mole accounts. I'll put an example. You have 5 mole of A, 2 mole of B, and 10 mole of C. You're going to divide every one of those by the smallest mole, which is 2. 2 is the smallest amount that you got. So you're going to divide everything just by 2. And then find the answer. And then the last part of the process is you're going to write the empirical formula. So you're going to get something where it's, A, B, C has this amount, that amount, that amount. And I'll put here that we found whatever it is was X, we found whatever this was Y, and we found whatever this was Z. Then we're going to put that here. There are going to be 2 common types of problems that students are going to be asked to solve. And this is where I come from, where I come in and show y'all just key things to look at. And 99% of the problems that you will come into dealing with when we're talking about empirical formula are going to be 2 types of problems. So the first one is that you'll get a problem that says that a compound is made up of X, Y, and Z elements. And y'all will remember that it's going to give you either in grams or mole. So you're going to be dealing with, it'll give you X grams. Oh no, let me do it differently. You'll have so many grams of X, so many grams of Y, and so many grams of Z. Or you'll have so many moles of X, so many moles of Y, and so many moles of Z. You can assume that that's all that's involved because they list it out. When it says a compound is made up of, you can assume that that's all that's in here. It's going to be a compound of X, Y, Z. Sometimes it'll also say only. A compound is made up of only. That's for sure that you know that this is all you have to worry about. There's no other surprise element other than X, Y, and Z involved. Okay? And then the second type that you're going to deal with a problem is that a compound has X, Y, and Z and the following percentages. And it'll say, it'll list out the percentages. If those percentages add up to 100%, two things. You know that you are sure that the only things involved are elements X, Y, and Z, and there are no other surprise elements that you have to look for. And then what you can do is you change. So I'm going to put, therefore, change percentages given 2 grams. So if it says, let me put down here. If it says 5% X, 20% Y, and 75% Z, you know you really have 5 grams of X, 20 grams of Y, and 75 grams of Z. Okay? Going to do some examples here. So we have a sample compound has 30.45 grams of nitrogen, 69.55 grams of oxygen by mass. That's all they list. A sample has this and this by mass. What is the empirical formula? So we have 2 elements that make up the compound. We can presume that. So what we're starting with grams here. And if we look at our little scheme that I made up, if you start with gram of each element in the compound, you go from gram to mole of each element in the compound. So we're looking at this part because we started at grams. We're not starting at moles. It doesn't say we have 30.45 moles and almost 70 moles. It's gram and gram. So we're going from gram to mole. So let's start here. I might make it a little bit smaller because I think I need space. So 30.45 grams of nitrogen. That's what we're starting with. We know we're going from grams to mole, so I'm going to put grams at the bottom. And then mole of nitrogen at the top. And I know this is going to cancel out. And whatever I get, my answer is going to be in mole. Okay, then we go to my periodic table. 1 mole of nitrogen is equal to 14.01 grams. Then once we do the math, it's 2.173 mole of nitrogen. Now we're going to do the same thing. We have 69.55 grams of oxygen per the problem. I started with grams at the top, so I'm going to go grams at the bottom. And then I know I can go from mole to gram in a conversion factor of oxygen. So whatever this answer is, it's already canceled out. My answer is going to be mole of oxygen. Then I got to do the math per the periodic table. 1 mole of oxygen is the atomic mass of oxygen, which is 16.00 gram. Do the math here. It's going to be 4.347. So now we have moles of each element that is involved in the compound. Mole and mole. We go back to our scheme. Once we're from mole, we got to divide each mole amount by the smallest mole calculated to get each element subscript. The smallest one here is 2. So then we're going to take both of them. I'm going to put nitrogen here, and I'll put oxygen here. For nitrogen, we have 2.173, and then for oxygen, we have 4.347. Which of the two is smaller, the nitrogen? So we're going to divide that by this one. And the same thing here. Divide by the smallest one for both. This is going to be 1. This one is going to come out to 2. So therefore, now we know the subscripts of the empirical formula. We have N, O, and then we can fill in the blank. N is going to be 1, so we don't have to write that, and O is going to be 2. So that is our formula, empirical formula. Okie dokie, let me highlight that. Next problem says, a simple compound is 19.8% carbon, 2.5% hydrogen, 11.6% nitrogen, and 66.1% oxygen. What is the empirical formula? Whenever it says percentages, remember I said there are 2 types of problems. A compound has X, Y, and Z in the following percentages. If the percentages add up to 100%, change those percentages given to grams. Okay, so I just need to do the math. And I'm going to do that here. 19.8, 2.5, 11.6, 66.1. Does indeed come out, but I'll just do it in the calculator really quick to double check the work. Oh, 19.8 plus 2.5. Yep, 100%. Therefore, it's 100%. So now, everything here I'm going to change to grams. So let's do... Let's see. Do we have room? We're going to have to make room. So 19.8 grams of carbon. I'm going to put carbon at the bottom, so it's 1 mole. Carbon, because again, when we start with grams, we go from grams to mole of each of each element in the compound to mole of each element in the compound. So that's the first step we're going to do. And then per the periodic table, the atomic mass of carbon is 12.01 grams. Once we do the math, that's going to be 1.649 mole of carbon. This cancels out grams of carbon. We end up with mole of carbon. And that's what that is here. Then we're going to do hydrogen. So we have 2.5 grams hydrogen. You know, at the bottom is going to be grams of hydrogen, and the top is going to be mole of hydrogen. Per the periodic table, atomic weight of hydrogen is 1.008 grams. Grams and hydrogen cancels out once we do the math. That comes out to 2.480 mole of hydrogen. Now I'm going to do nitrogen, 11.6 grams of nitrogen. Grams of nitrogen, mole of nitrogen. This is going to cancel out per the periodic table. That's 14.01 grams. And then per the calculator, that's going to come out to 0.828 mole nitrogen. And then for hydrogen, it's 66.1. I'm going to change that to grams of oxygen. 1 mole of oxygen, grams of oxygen, which is going to cancel out. Periodic table says it's 16.00 grams, not 1600. Let me put that decimal point. Wait, that doesn't look good. Let me write it better. 16.00. And the calculator says that comes out to 4.131 mole of oxygen. So we got all of our moles taken care of. So according to the scheme that I have, we're going from grams to mole. Now we go from mole to dividing each mole amount by the smallest mole calculated. The smallest mole calculated is, we have 1.64, 2.48, 0.284. This is the smallest one. So I'm going to highlight that. And I'll highlight that in the last problem. The last problem, this one was the smallest one too, nitrogen. Okay, so now I'm going to do carbon. What is hydrogen, oxygen, nitrogen. So for carbon, I have 1.649. That's how many moles I have. Then I have hydrogen has 2.480. Oxygen has 1.31. And nitrogen has 0.828. Okay, but I have to divide everything by the smallest, and the smallest is 0.828, so it's going to be zero point eight two eight, 0.828, 0.828, 0.828. This is going to be 1. That's the easiest one. For oxygen, when you do the math, it comes out to 4.98, which you can round up to 5. For hydrogen, it comes out to 2.99, which we can round up to 3. And then for carbon, it comes out to 1.999, which we can round up to 2. So, therefore, the empirical formula is C2H3O5N. Wait. Yes. And just for more context, that is right, but this is called a nitrate, and a nitrate's more specific formula to show how they are connected molecularly is C2H3O3NO2. But for this part of chemistry and chemistry 1, this is where you end, and you would have gotten the answer right. Follow me to some more practice problems videos that are linked in this description, where we're go over some easy ones and then some that are a little bit more difficult. See y'all in the other videos. It's linked below in this video's description.